Hello, everyone, and welcome to this episode of Just Solved It. On this video, we will be solving a problem, actually an integral given, by using the midpoint rule. So we're going to approximate these given x squared plus 3 dx with the limits 1 to 4, with n is equal to 4. So in the midpoint rule, we have this formula, which is the summation of n is equal to 1 with the function x sub n minus 1 plus x sub n over 2. Apparently that's an average formula, so there we go. We have seen the concept of the midpoint average. They nearly have the same principle, so they're here. Multiplying by the rate of change in x. So we know this formula already with the previous methods that we have been studying. So upper limit minus lower limit over n. So here in the given, we're going to solve for the rate of change in x, and we will have the answer 3/4. So we have now x sub 0 is equal to 1, then 1 plus 3/4 is equal to 7 over 4, plus 3/4 we have 5 halves, plus 3/4 we have 13 over 4, plus 3/4 we have 4. So here we go, x sub 0 and x sub 4 are the lower and upper limits respectively. So now we will be using this formula. So it's a summation, okay. So here we have x sub 0 plus x sub 1 is equal to 2. So 1 plus 7, 4, their values, over 2 times the rate of change 3/4. Same concept, so x sub 1 plus x sub 2 over 2. So x sub 1 is 7/4 plus 5 halves over 2 times the rate of change 3/4. So same procedure as we continue. After that, simplify the value inside the function. We have now 11 over 8, 17 over 8, 23 over 8, 29 over 8. And then these values, 11 over 8, we will be substituting in the variable x in our given, x squared plus 3. So 11 over 8 squared plus 3 will be giving us 313 over 64. Then we will be multiplying it by the rate of change. If we could also rewrite this at this stage, simply by having these common denominators. We will have 313 plus 481 plus 721 plus 1033 over 64. Then outside of the parentheses, we could just put the 3/4 there. So by solving that, we will be having the value or the approximation of 29.859375. The actual value for this integral is 30, just number 30, no decimals. So this approximation gives us a little bit of error, but still we are near from the real answer, or from the true answer rather. So that's the midpoint rule, everyone, and at this point I think we have just solved it.